Okay, so good evening, guys. Welcome to the MLOps workshop once again. Thank you guys all for actually joining me today again. And hopefully today we are going to finish with everything involving exploratory data analytics so that from tomorrow going, we can start pre-processing our data set and start building our model. So let me bring out our Jupyter notebook. Okay, so let me navigate to the directory that I am working in. And also I have to upload the data set you are using into the S3 bucket because it has already been destroyed. I think I'll, before this class, and I'll automate this process too because it shouldn't be so. So database. Just a minute, please. I'm coming. Okay. Let me rerun the entire notebook again. It's not supposed to be here. Yesterday we were having issues with that one. I fixed it later on. So let's wait while everything gets run again. Sorry about that. Okay, so this is where we ended yesterday, okay? We were able to visualize all the null values in our data set. So from here, we can see that there's a null value in the gender column. There's null value also here, and there's null value also here, right? And from here, we can see that our data set is not balanced. So going forward, we will have to balance our data set. Now let's do something. Let me first display the data set here. Okay, so now we are come to visualize, we are come to check something known as correlation. So what correlation simply means that it helps us to determine the relationship between the non-dependent features. That's these features over here from here to this side without the loan status. Okay, so we want to check if these features are, how should I put it, are highly correlated to each other. So let me give you an example. Let's say marriage, the marriage over here, married, and let's say something like gender. Okay, so let's assume that if we check the correlation and we see that this is highly correlated to this, and this one too is highly correlated to this, it means that what this can do, this can also do, and what this can also do, this can also do. So we will have to end up with deleting one because it's just going to make noise in our data set. They are all performing the same function. Okay, so that's what correlation simply means. It helps you to determine the relationship between these non-dependent features. Okay, so in order for us to do that, you are going to let me just finish writing this line of code and explain what I'm doing. Select data. Okay. So what this line of code is doing that it is displaying only the numeric features. Okay. So I'm excluding this categorical and object, meaning that I don't want any categorical features. I only want numeric values. So from this, I'm going to check if these features are highly correlated to each other. So in order for me to do this, I'll just add dot core. So yesterday, the reason why we're facing the error is because correlation, this method over here works on with only numeric features, not categorical features. So if, assuming I just do df dot core, you see there are errors because it doesn't work with categorical and object features. So example of a categorical feature can be gender, can be married, but it can work well with what these numerical features. So now we can see what our correlations over here, but let's visualize it. Let's visualize our result. Great. So this, you should keep one thing in mind that as a machine learning engineer or as a data scientist, drawing presentation is very good practice to make most of your stuff to be visualized. So that, I mean, explaining things which are visualized is much more clearer than things which are not. Okay. So let me explain what is going on over here. So let's see, we have applicant income over here, and we also have applicant income over here, and see the value is 1. Meaning that what this applicant value is doing, the applicant value also here is can also do the same thing. It actually makes sense because it's one particular feature. But if you check here, we have applicant income mapping to what? Co-applicant income, and we are getting what? Negative 0.12, meaning that the relationship between this feature and this, they are not that close. Okay, so let's assume our threshold. Let's say we have a threshold of, let's say, something like 70. So let me do it 0 point sorry, 0.7 like this, or 0.70. What it means is that if we check the relationship and this and this, the value here is 0.7 or 0.0, meaning this is highly correlated to this. So we'll end up either deleting this or this. So put in mind that correlation is a form it's a technique which helps us to select features. Assuming if our features are not just this one, there are more features in our data set, and we are trying to select some of the features. This is one of the techniques that we use by checking the correlations of our data set to see if the features are highly correlated to each other. So any feature which is correlated to another feature, we will have to decide which one to delete based on what the business of that particular application. So that's with correlations.
Hello.
Hello.
Yeah.
Yes, you can talk.
Yeah. Right. Please, can you take it again?
All right, sure.
Yeah.
Excuse me. So what I mean of correlation is very simple. Correlation is the relationship between two features, okay? Two or more features. So let me give you an example. We have let me use these values rather. We have applicant income and have what co-applicant income over here, okay? So
Yeah.
let's assume there's a variable A and there's a variable B, okay?
Mm.
And this variable A has value 100 and this value also have a value 100. They contain the same thing.
Yeah.
So they are in the data set is that they are just going to make noise. We can only take one and leave the remaining one. And this is a form of, it's a technique that we use to select features. So imagine if we have, let's say, 150 features, that we have to select the most important features. These
Yeah.
are some of the techniques that we can use to select them, and it's called correlation. By
Sure.
doing it this way, that I've just visualized it over here so that it will be very, very simple. So this is one, meaning 100%. And it's one because it's mapping to itself, applicant
Yeah.
income, applicant
Yeah.
income. So it actually makes
Mm.
sense. But
Yeah.
when you come here, we have applicant income, which is mapping to co-applicant income.
That's the difference.
Exactly. But when you come also here, we have applicant income mapping to loan amount. You should see that this is very low, 0.57 is a very low threshold. So it's okay. So
Yeah.
assuming if we're to get something like 0.70, 0.80,
Mhm.
depending on the business goal,
Mm.
we will have to set up a threshold that, okay, if it passes, if any value passes maybe 80, then they are highly correlated to each other. So we have to delete one. You get
Okay.
me?
Mm.
Yeah. But luckily, our data set even is not that much, and the features are not that close to each other. They are not having a strong relationship between each other. So we are good to go now. Okay. So
Okay.
now the next, you get it now.
Yes, I get it. I was just trying to draw the relationship with that and the other columns that you deleted. That's before this one. That's why I
Oh,
was a
okay.
bit confused. So
All right.
yeah.
Sure. So let me quickly display the data set again. Now we are come to do something. We are going to compare. No, let's do something else. In gender and male, let's see the maximum value in age. So let's say let's do something that something like gender. Okay.
Yeah.
So from we can see that there are more male than females. Okay. So what we are trying to see to the total number of male and female in our data set. So we want to see who which how should I put it? Can someone give me the right word?
What do you want to say?
Based on this diagram over
That
here, what can you say
diagram.
about it?
What do you say about this?
What can you tell me about what you are seeing over here?
The male is more than the female.
Exactly.
The
So what
males
are you
are giving more loans than the females, something like that.
So if you say that way, I'm not sure that's the correct answer, but we can check
The
if you
ratio.
want. So
Yeah.
male, no.
The male is more than the female. I don't know if. Yeah.
The ratio. Okay, just a minute. So remember we did something over here. We're trying to
It's
see
imbalanced. It's imbalanced, right?
exactly. But we can't say it's imbalanced because that's not what we are trying to search.
Yeah.
Okay. So what I'm trying to do here is that I just want to see who how many male and female exist. And based on this diagram, you can see that there are more male than female. That's what I want to
Yeah.
draw you guys your attention to. Do you get me?
Yeah.
Yeah. And you can also go further and add more visualization, like how I did with the how do I put it? With the pie chart too. So, but let me use a loop. Let me do something else. Let me get I'm going to get all the categorical feature names here. I'm trying to select the column names, both categorical and numeric.
It's not object now.
The
It's either
spellings.
integer. The norm is
No.
integer or float.
So here I'm trying to exclude it. So here I want object and category, but here I don't want it. So it
Okay.
will return the opposite.
Okay.
So now if I type something like
Oh, okay. Okay. So one has and the other.
okay, so these are the categorical features and these are the numerical features. Okay. But before we continue preprocessing our data set, we are not supposed to preprocess our data set, but see something over here. Let's check the dependent features. Let me show you something. Dependent feature dot value count. I want to show you something. You see there's this value here, 3 plus, right? But actually, it contains only numeric 1, 2, 3, 0, 1, 2, 3. But only this one, because of 3 plus, is treating it as what? A string, as a category, as an object. So where is it? Categorical. You see, we have dependent over here because of this. So if you want to check the type, let me show you. Check the data set.
Okay.
Check something. Dependent. You see, it's an object. It's not a float. So in order for us to explore this data set very well, we have to pre-process this column. So let me just do something over here. Process dependent feature. Under normal circumstances, we have to split our data set into training and test data sets before we process them. But what you are coming to do, it won't affect anything, so it doesn't matter. So anytime you come to perform processing stage, you have to make a copy of your data set. So this one will make a copy of we're going for it. We'll be using df copy. In case I make a mistake not using the df copy and I use df, let me know. So now I've made a copy of it. I'm come to process this dependent and make it numeric. So I'll just do at the same time, I will drop this value too because it's not necessary. So what I will do here is df copy, and then because df, and then dot replace. I want to replace something over here, and that's going to be something like was it plus 3 or 3? Let me see. 3 plus. I want to replace anything from here to let me see. You see, I made a mistake here. You guys didn't notify me. DF copy.
DF copy.
Yeah.
Okay, fine. I was thinking, why don't we just create a DF copy, like, and then like put it there, and then that's what we'll use throughout. What do you think? So that we don't be forgetting always to do DF copy, like at the beginning.
Remember, we are making a copy of the data over here.
Yeah.
That's what I've named the DF copy. Anytime you perform, you are trying to make a change in a data set, like pre-processing something. It's best practice.
You've done it. Oh, okay.
Exactly.
Because
so I'm the one who just made
looking,
a copy.
Yeah, I didn't see the underscore. I thought it was
okay. Let me see if I don't face any issue. Okay, it's actually working, but let me see something over here. Oh, no, not here. So it's still there. Yeah, I think I have to add something called in place. Oh, it's true. Let's see. So let's see. It's still there.
No, it's copy. It's not copy.
Oh yeah. Thanks, eh. df.value. No. Oh, sorry. Good. I'm doing something wrong. Let me see. Okay. Let me use this command. Oh, come on. Let me see. Error. Where is it? Type set. Place. Wow. Let's go to Google. Wow. Okay, let me see. Let me see something.
I sent in a chat. Try and see whether
All right. Thank you. I think this was what I did first time, or so I want to replace this with there. Okay. Now let's check it over here. Why is it? Okay, let me do something. And then now, so we have to replace it with none, none, none. Nope.
Is it because it doesn't see it as a float or something?
No, so wait, let me see.
I'm just guessing. The dependence.
Plus. But the value is supposed to be 4. And the reason being so, okay, it's working.
Okay.
Who can tell me why it's supposed to be 4? I've forgotten. Why are we
Right.
replacing it from this to 4?
it's an ordinal distance. So it has 1, 0, 1, 2, 3, 4. So and it's
Exactly.
3 plus. So
Exactly. It's 3 plus. So it can be 3, it can be 3 itself, 4, and 5 going. But I already have, if I'm not mistaken, there will definitely be 3 inside. But anyway, let me quickly convert this one to, even though we've changed it, it's still not a float number. Let's see, dependent.
The four should be, there shouldn't be any semicolon. There
It's
shouldn't
still
be
object.
any that column there. You have to,
I think it will throw an
it
error,
has to remain like 4 without any.
but still, okay, let's check it here and see. See, it's still dependent. It's still object. So we have to manually convert it ourselves. Okay.
Yeah. You need to change the type. The
VPD. Let me confirm over here and see something. See, can you see now? It has been moved from what? Object to what? Float 64.
floats. Yeah.
Exactly. So let me quickly give my comment. Where is it? And we are good to go. So now let's run this thing again. So now the numeric, let's see if we have the dependent. Is the numeric? Does it have the? Oh, okay, I'm still using the. I think I'm using the DF.
You're using DF copy.
No, at first I was using DF, so let me change it. So now we have the dependent being part of the numerical features. Okay. So now let's see how the next thing we are supposed to do. Let's display the type here. Okay, so we are good to go. Now let's do something else. So what this is doing, that is giving us some overview of the data set. Okay, so it's saying that what it has C616 null values. Okay, the the values which are not null are hot. 614, see it has counted it and it's telling us the data type. So these are all objects, and we have this being what numeric and this to being objects. So we'll convert all these things during our pre-processing stage. Okay, but I think I saw the loan ID. I said we will remove the loan ID, but it skipped me. So let's do it here. Remove loan ID from data sets. Copy. So it has been removed now. So here you can see we have a loan ID over here. It won't show there anymore. See, there's no loan ID. Okay. There's no more loan ID. Let's see. There's no loan ID. So now you can see that what we've done some exploratory data analytics, and we've done somewhat visualizations, but we are still not done. Let me display the entire data set again. So the next thing that we are going to do is we are going to do some comparison. Let me write what I want to do and explain. I mean, with SNS constant, yeah. Oh, sorry.
Hello, I have an observation. Sorry.
You can talk, I'm listening.
Okay, like I don't see like 3.0, right? Like if we check the number of the unique values, like is
Yeah.
0, 1, 2, 4. There is no 3. Even though it was 3 plus, is it going to have any effects?
Okay, so based on my experience, so far as it's 3 plus, if it were to be in real world and I'm working with such data set, I'll definitely not use 3. I'll use 4. The reason being so is because it says 3 plus, right? If I use 3, meaning how should I put it? It's like I've limited it, but if I add 4, meaning 4 is ahead of the 3. I don't know if you get me.
Yeah. Okay.
Okay.
Yeah.
You're welcome. So I think Destiny, I want to do something. So that's what I want to achieve.
It's
So
copy. Copy. Sorry.
yeah, thank you.
Okay, good.
So okay, sure.
Coming, I'll explain what I'm doing over here. I'm coming. Just a minute. Just a minute. Who can tell me what's going on over here?
Are you plotting, trying to find some correlation between two?
Nope.
Uh,
It doesn't have anything to do with correlation, but
let me see.
who
Can you
can make an
scroll?
observation?
It's
Can you scroll up a bit?
That's what I'm trying to do, but when
It's
I do,
not.
it goes too much. Okay, I think
Yeah,
this one
there's
is
a scrolling bar on the far left or right. Maybe you can
no.
scroll up. Far
Let me
left.
just give it one. Yeah. So what's going on over here?
So you want us to interpret it or something?
Yeah, I want someone to interpret it for me. Okay. I thought someone sent a message over here.
No.
Okay.
okay.
Okay, Gideon, I'm listening. You can speak.
Hello. Yeah, can you hear
Yeah,
me? You're talking
yeah,
about the
we can hear
visualization,
you.
right?
Yeah.
Okay.
Yeah,
Yes.
yeah. So
We have what I can see is yes and no. When you get to the no side, we have the
mhm,
female and the male. So you can see that the blue
No, it's
represents the
very
female,
low.
and you can see that the female is very high. And when you
Yes,
go to the yes side, you can see
very
that the
dark.
male, the majority of them is, what should I say? What should I that color? Let me say that. So that's the interpretation of that side. So
good. So that's correct. So what you are trying to actually do is to check between male and female. Okay. Uh, oh, sorry. I thought someone wanted to speak. Okay. So what we are trying to do is that we want to see those that loans were granted to, okay, and those that loans were not granted to, between male and female. Which one of them were many? That's what you are
Male.
trying to achieve. Like, do you guys understand?
Yeah.
Exactly.
Yeah.
So I'm coming to do something else too here again. I want you guys to interpret it. What? Uh, so now I want married. I want dependent. Let me see. Let's choose education. See that I'm not using the DF copy. Okay. columns. Okay, good. Now let me visualize this, and someone should also interpret this one for me. Good. A minute. Okay. Who can give it a try?
Do you want someone who has not spoken or anyone?
Or anyone who wants to just let me know. Who wants to give it a try?
Okay, so let me try. Let me attempt. I think Tim sent something. Yeah. Should I continue?
Oh yeah, you can talk.
Okay, so like my brother said, Gideon, Jima, it's separated into there's a no side and then the yes side of the chart that we are looking at. So under the no, we have different like categories. Categories, am I right? Yeah, categories. So we have the graduates, and we have those who are not graduates, and then we have so yes, so we have we have married and education, the major category. So we have a mixture. We have oh, this is tricky.
Okay,
You can take it.
I try.
Promise, save him for us.
No. Okay, so we are trying to check the approval or status of loan across those that are married and are graduate, or those that are not graduate and married. So among the two columns, right? So married and education are two columns, and inside them they have two categories: either you are married or not, or either you're a graduate or not. And so we're just it's like a cross tab, right?
Oh, okay. So the options for education are either graduate or non graduate, and the options for marriage are either yes or no.
Yes.
Oh, I see.
So still, it's not clear to me. I didn't get it well.
Okay,
Really?
please continue.
Yeah.
Please
And so
continue.
now, example, let's say yes and graduate, right? They have they are giving more loans than than the others. It has green. This green, this thing is the highest in Y. That is yes, and so they are giving more loans than the not graduates.
Good. So what she's trying to say is that those who were married and graduate, okay. So let's take the first one. Those who were not married and were graduates, okay, were given loan, okay. More than those who were giving loan are more than those who were not giving. So let's take this one, this blue, okay. We are targeting this blue. Please pay attention. We are saying that those who were not married, but they were graduates, okay, they were giving loan more than those who were not giving loan.
Okay.
Is it clear?
Yeah.
And those who were not married and at the same time were not graduates, those who were giving loan were also more than those who were not giving loan.
Okay.
And those who were married and at the same time graduate, they were giving loan. Those who were giving loan are more than what? Those who were not giving loan.
Okay.
And coming to those who were married and not graduate, those who were giving loan are more than what? Those who were not giving loan. I'm doing this. The reason why I'm doing all this is because I want you guys to understand everything so that you can generate your own visualization you can generate your own visualization, because remember, you are going to represent, let's say presentation, you're going to present to people who don't understand this. Imagine if you show this to someone, this.
Yeah.
I mean, it won't be clear. I will never understand what you mean. But if you show this to someone, at least Promise was able to interpret it. So visualization is a key that you should get. In fact, it's a skill that as a machine learning engineer or a data scientist, you should get. Let me show you something. Let me show you a project that I worked on some time ago. I think that was 2 months ago. Let me go to my GitHub account. So there's actually some loan thing. I think there's a logistics something, linear regression application that I worked on. Okay, it's a regression machine learning application. So let me show you what I meant by. So there's actually MLOps on Microsoft Azure that I did using Azure DevOps. Is it Azure DevOps? Let me see. Yeah, it's Azure DevOps. So see, what we are doing is the same thing that we are also doing. There's nothing different. See, I imported my libraries over here. I imported my data set. I did my visualization. It's just that you just have to it's just one way. If you understand what you are doing, the moment you build one project, you can use the same syntax to do almost half of your project that you'll be working on. Then the next thing I did was to write some articles. I even wrote 3 of them, part 1, part 2, part 3. And the last one I did was to explain how everything was built. I think explain how the model was deployed using infrastructure as code and CI/CD pipeline with Azure DevOps. I've explained everything. What I'll do is after this class, I'll share this link with you guys. You can go through and see how I did this one, because we won't be doing anything related to regression. Okay. So what I showed you, you could see that what I'm actually trying to apply the same things over here, because I understand what I'm doing. It's actually the same thing. So now, what should we do? What do we want to compare? Let's say we are a machine learning engineer and we are trying to understand the data set, okay, that we are working with. You should be able to make different, how should I put it? Try to analyze the data. So now what do you guys want to see? Forget even about the loan status and everything. What do you want? Okay, so okay, fine. So me, I want to see those who are married.
Right.
I'm listening.
Like example, I would like to know if there are outliers in the data set. I want to know if like describe, trying to check the mean and so on. Yeah.
I think I did that. Okay, I didn't do it over here. So let me just do it. So fine. Well, let me change it this way. I like it this way better. So you want to see if there are outliers in our data sets. And how are you going to know? We are going to check.
Can we use the box plot to see
All right.
outliers?
Okay, sure.
It's just a suggestion.
Let's see. Let me use dependent. But let's do it this way. Let's use a loop. A loop will be better for display outliers in our data set. So for columns in EF copy dot select E types. I want to exclude category and objects. So now dot column will give me all the column names. So SNS dot box plot. And if I bring DF copy, then column, let's see what we have over here. Let me see. Just a minute. Who can tell me the reason why my loop is not trying to plot all the numeric, but it's only picking one? I hope you guys understand the line of code over here, right? Okay.
Yeah.
So okay.
Yeah.
All right. So I thought that you had earlier put categorize them into numerical and categorical. So why don't you just use that numerical and not just DF, even though it's the same thing? I don't know if you understand.
I think I used DF copy. I thought I used DF. Okay. Okay. So giving us one value.
One value. It's displaying one column.
It's actually picking one value to show us if the outlier in it. So let's see. Let me display the name earlier. It's actually using the credit history. It's only picking. Let me display the data set, the entire data set here, so that we will know. It's picking only this.
Credit history. Is it because of the data type? I mean,
no.
Data type.
They are all numeric.
Like floats. What kind of? Okay, fine.
So based on this credit history, is there any outlier here?
Yeah, 8,000 or something.
Okay, Gideon, I'm listening. Gideon.
Yeah, bring plt.show at the end. Let's see if it will get all there.
All right. So it's actually working, I think. All right.
Okay.
Okay.
Different
Thank
ones.
you. So who can tell me if there is any outlier over here? Let me see. Oh.
Jupyter notebooks.
So let's take the first one, dependent.
Yeah.
Is there any outlier in the dependent?
Hello. Yeah. Hello.
Is there any outlier in the dependent feature?
No, I don't think so. I don't think so.
Is yes or no? Exactly. There's none. What of applicant income?
There is
a lot.
Okay, so you are saying one applicant income. No problem. Okay. So let's move on to
applicant
income.
Go applicants. You can see it.
So we have that one outlicensing. Okay. What of loan amount?
Yeah, same. It's beyond the range.
Then loan amount term too. Will you say?
Yeah.
Yes, outlier in it. Look at the road. Loan amount term. This one.
Hey.
No, there's no It's not much because okay.
I'm listening. In fact, I want you guys to take a picture of this one. That's our assignment for today.
This will be a Google Lens.
I'm serious. Please, just take a picture of it. Just before just take your phones to just take a pic of it. Okay, let me see it.
Let's say video.
Gideon, Rodney, promise. I'll definitely take these things from you tomorrow. Please take a picture of it, because Promise merely gave an answer. It's like she's scared of what she's about to see. Is it clear now?
Okay, like okay,
I don't
now before I can comment on this, unless we check for the
unless you do what? Unless you check the minimum and the maximum value.
I think we should check for the distribution plot.
Okay, sure.
No, I think we should visualize the distribution plot to see
Can I take
clearly.
a screenshot like one more time?
Okay,
sure.
I'm coming just in it. He's saying something, so let's do that right now. Let me do something. Just a minute.
Kind KD.
Please just give me a minute. It's okay. Okay, so where were we? We were here. No, here. I'm listening. Or you've all left.
This one.
We are here. So
okay, so are there any outliers? Rodney, don't be there and say you want to say so that you take the credit too.
Okay, Jima is saying something.
Oh, there's outline since it has been skewed to the left.
Is this left or right
outline
skewed?
since it has been skewed to the this left skewed.
This left skewed, right? Good. So fine. Let's that's what loan amount term. Let's come up here.
Left skewed. Yeah.
Loan amount. Where is the minimum? And there's the maximum. Good. Gideon, you're the one who provided the answer, right? Is it Gideon? Hello?
Yes, I think so.
Okay, Gideon. Can you hear me, Gideon?
Yeah.
Can you hear us? Can you hear me?
Yeah, I'm here.
Okay. I want you to explain why is right skewed and
I'm here, I can hear you.
I want you to explain why it is right skewed, and based on that, you're able to know that they are out.
Yeah, I can hear you guys. I can hear you.
I want you to explain why, first of all.
Hello, can you hear me?
We can hear you. Can you also hear me? All right. Let's just leave him since I think he has issues with his network.
Yeah, I mean we can send it to the chats and he can.
Okay, yeah. Let me quickly do that.
Yeah, I can hear you.
You can hear me now.
Regardless, just put it
in the chat. Now?
Yeah, I can hear you. Can you also hear me?
I think he hears us, but it takes time.
Yeah, let's just, because when he starts to explain, it will take time. Let's just keep it for now and let's move on. So now we
I can hear you guys.
Yeah, we can also hear you.
Yeah, I can hear you.
Anyway, let's just move on. Let me. Yeah,
What
I can hear
about
you
now? Can
clearly.
you hear me now?
Okay. So now what do we also want to see again? Now we've seen that we've realized that there are outliers in our data set. So how are we going to deal with these outliers?
Are we going to throw them
No,
off or
we
something?
can't just say we are dropping them off just because they are outliers. There are different techniques of
How to check them?
come again.
I believe that we have to check them individually to know if they are important to our
Data. Okay, sure.
yeah.
So
So if it's not really important, like depending on the domain knowledge, right? If it's not important, then we'll just discard it. But if it's important,
good. I like your response rather. Your own is okay. In fact, we can't just be dropping the features in our data set just because there's a null value and just because they're outliers. We really have to use domain knowledge. So if you are working on this data and you don't have any domain knowledge, you have to seek help from someone who is an expert in insurance company, insurance industry, and any of these banking sectors for him to explain certain things. So let's see, based on the little knowledge we have, I think the only data set which does not have is this dependent, okay, an outlier. Aside that, all the remaining ones has outliers in them. So what, based on what we have seen so far, let me just quickly display. Let me see. Okay. Aside the dependent feature, applicant income 1, 2, 3, 4, 5. They are all wait, credit history. Let's check credit history. Credit history. Wow, see, can you guys see what I'm seeing over here? Credit history, we have 0.0 as the minimum and the maximum is 1. But let's see what the graph is telling us. Oh, okay. Sorry about that. Okay, so the credit history and dependent are out. Now you're left with 1, 2, 3, 4. So based on your little knowledge you have in finance, is applicant income important to determine whether we should give loan to an individual or not?
of course, it's very important.
100%. What of
Yeah.
co-applicant
Yes.
income?
Yes.
Yes.
Income is important.
Then what of the loan amount that the person wants?
Yes.
Is it?
Of course, it is very important. I mean, let's assume we know you are rich, you have you are making well, and you come and you want billions of dollars. Does it mean that we should just give it to you? So it's also necessary for us to determine whether we should give you a loan or not. What of the loan amount term? That's what I don't know. So in our case, we are going to assume everything is very important over here. So your first assignment for today is very simple. Techniques to deal with outliers. Okay. And what are the techniques to deal with outliers? Let me give you a hint. We have Z-score and we have capping. When are we going to use Z-score and when are we going to use capping? No, wait. I think is Z-score and something else. I'm coming. I have them over here. I don't want to give any wrong information.
Okay.
Z-score handling outliers and
Okay.
just a minute. Yeah, interquartile. This method.
The quarter reach.
So it's rather Z-score. So in Z-score and in the interquartile range, that's when we have capping and trimming. Okay, so it's like this. Let me show you what I mean. So we have Z-score and IQL. Okay, so this is the difference between Q1, Q3 and Q1. So here you can either use trimming or you can use capping. Same apply to this one.
Filter.
It's time. Oh, trimming and capping. So please find out when we are supposed to use Z-score and when we are supposed to use IQR and the code for it. Okay, so you can always access this notebook. It's public. I'll push it to GitHub. You can always access them and see the diagrams over here. Then please, I'll get it tomorrow. Promise, Gideon and Rodney. Okay. Okay. So is there any question for me for today? It seems like we are almost running out of time. Is there any question for me? If anyone has a question, let me know. Gideon, Promise, Rodney, Akim, Kojo. If anyone has a question, let me get it now. It's almost time.
Yeah. So the first you dropped
Are we
off
done
some
with the
columns at the beginning.
analysis? I went off.
Oh, okay. So no, we are not done. I have given an assignment that we have to deal with these outliers, right? So the first question is, normally we have two ways of dealing with outliers. We have using Z-score or IQR, and under it we have capping and trimming. So the question is, when are you going to use Z-score or IQR? That's the interquartile. When are we supposed to use phrase to handle outliers? That's the assignment for the day. And we are done because it's almost time. So probably we'll continue on tomorrow to explore the data set more. I mean, we've done a lot. Tomorrow we'll just do simple one or two things. Then we'll start pre-processing our data set by splitting it into training.
Oh, okay.
Okay, so I want to ask a question.
Okay, I'm listening.
No, okay, I think Akim, he wants to ask a question.
No, you can ask just first.
Okay. Like the usual way or conventional way, is it to split the data before feature engineering, pre-processing, or the other way around? Like I'm really like confused. I've seen online like you have to clean, you have to do the engineering, then you now split and you do the model building. But I also heard recently that it's a wrong process, that you have to split first because of data loss or something. So
let
but
me
I'm
explain.
okay.
Let me give you an example of something using one hot encoding. Okay. So we have
Yeah.
something called one hot encoding. And we will be using this to convert all the categorical features into numeric. Then after that, we are going to scale them. The reason why you should split the data, because when you initialize something like this one hot encoding, let's assume it's something like this, and you use oh.fit. Okay, we use fit on only training data set because the moment you fit, it's like it's learning patterns in the data set. And assuming if you don't split it into training and test data set, it's going to learn from both the training and test data set. And when you start building your machine learning model out of it, it has already seen the data.
Yeah.
So it's going to give you better results, and you may think that your model is performing well, but it's rather under overfitting.
Yeah.
Okay, so it will be training good on it will be performing well on the training data set, but it will be performing very bad on the test data set. So it's always advisable to split your data set into training and test before you can start pre-processing on your data set. Are we cool?
Yes, thank you.
You're welcome. Yes, Akim.
Yes, I wanted to ask that is it necessary for machine learning ops to know all this?
machine learning engineer or MLOps engineer?
MLOps engineer.
Okay, good. So as an MLOps engineer, to tell you the truth, I don't see how you are going to even build your pipelines if you don't understand everything we've done so far. Because the reason you say is because, let me show you something. Imagine as an MLOps engineer, you've been given a notebook like this, okay? And they've asked you to automate. Most of the times, some organization will will ask you to automate this visualization and be saving it into an artifact. And at the same time, the pipeline that we are going to build is going to handle all these things before it build the model, trains it, evaluate it, run unit tests, and deploy it to whichever environment that we want. So imagine if you don't know these things that we are doing over here. I mean, if you get this notebook, you are going to see it as something very strange. Do you guys get me?
Yes.
Exactly.
Yeah.
So it is actually important that you understand what we are doing here. It is very, very important. You should understand it. If you don't want to code it, fine. But you should understand that when you see this kind of stuff, this is what it means. And that else you are going to really not going to enjoy the ML ops role, even if you get the job.
Okay.
Any other question? All right. So since there's no other question and there's no time, since our
I
time
have
is
a question.
almost. All right,
Hello.
Gideon. Yeah.
Yeah, like Promise asked you a question. You said that we should. Is the best way that we should go about it is to split first before we encode, right?
Yes.
Yeah, but what if a situation whereby like our data set right now is categorical and also it's not balanced? So what if we want to balance it? Because you uh, when we want to balance it, I think you have to use I think smooth, right? When we're using smooth to balance
Yeah,
it,
smooth. And
first let all the data should be numerical. I mean, you have to encode all of them before you can split. In the case where you want to balance your data.
Okay. Let me give you one example, Gideon. When you are balancing your data, you are actually making how should I put it? It's like if you're using undersampling and oversampling. I've forgotten the two, but
What
one
should I
is
say?
making
Categorical, and you want to use one word encoding to change your data into numerical. Do you have to still, because you can't, I don't know if you can have a way, you can't split a data with categorical features when you are want to balance it using smooth.
great. So let me give you some. Let me explain something here. I'm coming.
Is
It's
my
almost
question correct?
yeah. Your question is actually clear, but when you want to handle imbalanced data sets, why are you handling the imbalanced data set on test data? Remember, test data is mimicking the real world example, and in the real world, they are not going to generate any random data. Okay, so handling of unbalanced data set, I know of two, but I know there are more. We have undersampling.
undersampling,
And
oversampling,
oversampling.
smooth.
Smooth. Okay, good. These two, between these, one is adding more data, and which one is adding more and which one is reducing? I think oversampling is,
It's
so
added.
let's think that, yeah, so let's think oversampling is adding. So let's say if we have A to be 10 and B to be 5. Oversampling will make sure that B becomes 10. If I'm not mistaken, then undersampling, if you are using of undersampling, it will make sure that this will reduce to what? 5. I've forgotten the two meaning, but the question is testing. Like you are trying to use the test data set that we are going to use is like you are using it to mimic the real world. So why do you have to make a duplicate of it again? It's advisable to rather handle this imbalance things in the training data set because you need more data to train. You don't need more data to test. Gideon, can you hear me?
Yes.
You need more data to train. You don't need more data to test. I mean,
Okay.
when you are testing your application everywhere, you're not going to use huge data. But when you are training your model, you need more data. So I always split it first, then handle if I have to work with numeric data, I'll split them into both categorical and numeric, handle each separately, convert them back, then go my way. I will never handle this imbalanced data set on both the training and test data set. It's not advisable. Is it clear? Gideon.
I think
It's
it's
clear.
networking.
It's clear.
Oh, okay.
It's,
Okay. Okay.
yeah, we got it.
All right. So always make sure that you balance you split your data set into training and test data set before you start working on it, no matter what it takes. Even if after splitting, you have to redivide them into numeric and category. Do it. After that, you join your things back and you are good to go.
Yeah, I think he has joined.
Okay. Gideon.
Can you hear me now?
Yeah, we can hear you.
So please, did you hear my question? I think I lost in the way.
Wow. Okay. Uh I was saying that anytime you are dealing with any technique which involve pre-processing and feature selecting, just split your data set into training and test data set and find a way to work on it. The reason being so is because we are using, when you are testing application, we don't need huge data. It's only the training side that we need more data. Why do you have to make a duplicate of your test data? It just doesn't make sense. Gideon,
Yeah.
can you hear me?
Yes, I can hear you.
Okay, good. So why do you want to handle imbalanced data set on the entire data before you split them?
Okay, like what I was saying is, I was working on a certain project. What I did was,
Mhm.
I balance the data using smooth. Now, before you can use smooth to balance the data, it has to, like, all of the data should be in
In numeric,
historical features first before
it,
you can balance them. Then you
it
split
has to be
them.
in numeric, right?
That's what I did.
All the features has
Please,
to be in
do you get my
numeric,
question?
right?
Do you get what I'm trying to say?
Gideon,
So before you can use smooth
Gideon.
on a data, like all of them should be in numeric
I think he's
before you
hearing
can
you.
use smooth on data.
So
Now,
if he says something,
smooth,
his
you have
response
to
is
balance the data. Then right from
yeah.
balancing the data, then you split. So you can't use
So why don't you listen?
like this data, for example, it's not balanced. Now you have to balance the data. You have to use smooth to balance. Now before you can balance, you have to encode in case there's any categorical feature inside. So should we still apply your own, like you have to split the data first
So
before
fine,
we can encode? Now I'm talking from when you want to balance it.
I get you. So if I were you, I will split both into training and test data sets. Remember, you don't need many data
Hello,
to be hello.
hello.
Remember
Yeah,
that
you
you'll be
hear.
using one hot encoding to handle. Wow, this is really
Yeah,
going to be
you can continue. He will hear you later. Like he's hearing you in the future, like in the past. So you continue.
okay, sure. So the thing is, when we are trying to handle imbalanced data sets, it's only needed in the training data set because we are training and we want all the data from both sides to be equal for the model to perform well. But when you are testing your model after the model has been built, that is no more needed. So there's no need for you to handle test imbalanced data sets in test data sets. It's just not the right way to do. Always try to split your data set into training and data set. Work on the training data set for the imbalance. Make sure it is balanced. That's what is important. The training data set not the test data sets. That's all. Does anyone else has a question? Maybe he will have to watch the video and try to understand what's going on. Does anyone else has a question? Okay. So if there's no other question, let me see. I think we will just have to end here. I don't know. I hope you guys remember how I have been clearing this thing up, creating a new branch and all that, right?
Mm-hmm.
Do you guys remember? It's very crucial.
Yeah.
Okay. So from here, I'll actually do that, pull everything to the repository, then clean up my account to prevent any future charges. So if there's no other question from me, Gideon, from here, I wish you will call me. I can spend 10 minutes with you so that we'll sort this thing out through WhatsApp. So if there's no other question, let's just end the session for today. And thank you guys all for joining me. I really appreciate it. I'm sure by tomorrow is Wednesday. Wow. Please tomorrow do come early so that we will try to build our machine learning model and start doing the automation probably Thursday. I didn't know tomorrow is Wednesday. We are actually running out of time. I want us to finish everything exactly as planned, like Friday. So let's just end for the day and meet tomorrow. Thank you all guys for your time.
Okay. Thank you.
All right.
Yeah.
Guys.
Can
All
I
right.
see you after? Like